You know, from Doctor Who's TARDIS to the DeLorean and Back to the Future, we are just obsessed with the idea of time machines. But is any of it real? Could we actually do it? Could we journey through time?
So let's get right to it. Is this whole idea just a fun fantasy for the movies, or is there some real hard science that says it might actually be possible?
Well, let's just rip the Band-Aid off right now. The first thing you need to understand is that time travel isn't just possible.
It's a real, measured physical fact. But, okay, before you run off to build your own time machine, I gotta be clear. It is not at all what you've seen in the movies. See, right now, all of us are traveling through time. We're all moving forward at a pretty steady rate of 1 second per second. But here's the kicker. What Albert Einstein figured out is that this rate isn't fixed. The universe has a speed limit, the speed of light, but it has no fixed speed for time. And his incredible theories gave us the actual blueprints for how to change it.
So, if we want to go to the future, how do we actually do it? Well, it turns out there are two proven engines that make a trip to the future a scientific reality. Let's take a look.
Einstein's brilliant theories of relativity give us two completely different ways to play with time. The first one, which comes from his theory of special relativity, uses speed. We'll call it the velocity engine. The second one, from general relativity, uses gravity. Let's call that the gravity engine. Okay, so first up, the velocity engine. The idea here is actually pretty simple. The faster you rocket through the 3 dimensions of space, the slower you travel through the 4th dimension, time. This effect is called time dilation, and it leads to that famous thought experiment, the twin paradox. Imagine one twin stays on Earth, while the other blasts off in a spaceship traveling close to the speed of light. When the traveling twin comes back, they will have aged way less than their sibling on Earth. For them, maybe only a few years have passed, but for everyone back home, it's been decades. They've literally jumped into the future. And then we have the gravity engine. Einstein's big insight here was that gravity isn't really a force, it's a curve in the fabric of space-time itself. So think of a massive object like a planet as a bowling ball on a trampoline. It creates a deep dent, or a gravity well. The deeper you are inside that well, meaning the stronger the gravity, the slower time actually passes for you. And this is real. It's measurable. Your head is aging just a tiny bit faster than your feet, all because your feet are closer to Earth's center of gravity. Wild, right?
Now, I know what you're thinking. This all sounds super abstract, right? Like this is all just theoretical physics. But what if I told you that you rely on these principles of time travel every single day, using a device that is almost certainly in your hand or your pocket right now?
Okay, so check this out. This table shows this constant relativistic tug-of-war that's happening on every single GPS satellite orbiting our planet. On one hand, because these satellites are moving so incredibly fast, special relativity says their clock should actually tick slower than ours down here. But, on the other hand, because they're so high up and in a much weaker gravitational field, general relativity says their clock should tick faster.
So, which one wins? Well, when you do the math, the gravity effect is stronger. The clocks on GPS satellites run ahead of ours by a net total of 38.6 microseconds every single day. Now that might not sound like a lot, but if the engineers didn't precisely correct for this time travel effect, your phone's GPS would be off by about 10 kilometers a day. It would be completely useless. This is the ultimate proof that time travel isn't just theory, it's a daily engineering problem that we've already solved.
All right, so traveling to the future? Check. It's an engineered reality. But what about the one everybody really wants to know about? The Holy Grail, going back to the past. This is where we have to leave the world of proven physics and enter the wild, weird world of theoretical loopholes in the very geometry of spacetime.
So, to even begin to talk about going backward in time, we have to introduce a key concept. It's called a closed time-like curve, or a CTC. Think of it like this. A normal path through time is like a drag strip. You're always moving forward. A CTC, on the other hand, is like a circular racetrack. It's a path that literally loops back on itself, allowing you to end up at the same point in time where you started.
So where would we find one of these CTCs? Well, Einstein's equations are surprisingly flexible, and physicists have found a few bizarre theoretical scenarios where they might exist. The most famous one, of course, is a wormhole, a hypothetical tunnel that acts as a shortcut between two different points in spacetime. Another idea involves something called cosmic strings, which are these incredibly dense theoretical defects left over from the early universe. And maybe the weirdest of all involves a specific type of rotating black hole, whose singularity isn't a point, but a ring, that you could, in theory, fly through to access a path to your own past. But let's just pretend for a second. Let's say we could actually build one of these machines. We flip the switch, and we immediately slam into a colossal problem. backward time travel seems to break logic itself. It creates paradoxes that threaten to tear apart the consistency of the entire universe. You've all heard this one, right? It's the classic grandfather paradox. What happens if you go back in time and stop your own grandparents from ever meeting? Well, then your parents are never born. And if they're never born, you were never born. But wait, if you were never born, then who went back in time to stop them in the first place? You see the problem? It's a logical contradiction that just can't exist.
And if that one doesn't bend your brain enough, how about the bootstrap paradox? This one's a bit more subtle, but just as weird. Imagine you're a huge Shakespeare fan and a time traveler. You decide to go back in time and give Shakespeare himself a copy of Hamlet. He loves it, copies it out, and it becomes a classic. Centuries later, you come along, pick up a copy of Hamlet, and eventually take it back in time to him. So, who actually wrote Hamlet? It has no origin point. It was just bootstrapped into existence.
So how does physics try to get us out of this logical mess? Well, there are basically two main schools of thought. The first one is called the self-consistency principle. It basically says the past is set in stone and you can't change it. The laws of physics themselves would literally conspire to stop you. You could try to shoot your grandfather, but your gun would jam, or you'd slip on a banana peel, or a bird would get in the way. Something would always stop you. The other solution comes from quantum mechanics, the many worlds interpretation. This one says you can change the past, but the moment you do, you create a brand new branching timeline, a whole parallel universe. So you might save your grandfather in that new world, but you can never ever get back to your original timeline. Okay, so even if we could somehow get around the paradoxes, there's a final, even bigger question. Could we ever actually build one of these machines? This is where physics delivers its final verdict. And it seems that even though the math might allow for these loopholes, physical reality slams the door shut.
The physical barriers are just, well, they're staggering. For one, those theoretical wormholes are wildly unstable. They would collapse in on themselves the instant they formed. To prop one open, you'd need a huge amount of something called exotic matter, a substance with negative mass and negative energy that we have never seen and may not even exist. And even if you found some, the energy required to do any of this would be astronomical, maybe more than the total energy of our entire sun. All of this led the legendary physicist Stephen Hawking to propose what he brilliantly called the chronology protection conjecture. He basically argued that the universe has its own built-in security system. He theorized that the laws of quantum physics would create a violent feedback loop of energy that would destroy any time machine at the very instant it was about to work, fundamentally protecting reality from the chaos of paradoxes.
So, it seems a physical journey to yesterday is off the table, at least for us. The universe just won't allow it. But this leaves us with one final tantalizing question. If we can't send a person back through time, could we send a message? Could we one day whisper a warning or a secret to our former selves? Well, the physics of that? That's a story for another time.